Hello everyone, welcome to the second tutorial on antenna designs. In my previous video, I designed a patch antenna at 5 GHz using probe feeding, that is, I fed using a coaxial line. But in this tutorial, it is going to be the same 5 GHz patch antenna, but I am going to feed using inset feeding technique. So these are the basic calculations. I'm using a Rogers 580 with a dielectric constant of 2.2 as the substrate material that has a thickness of 0.76 mm or 60 mil, and at 5 GHz our lambda is around 0.06 meter, whereas using the dielectric of 2.2 the lambda g guided wavelength will be 40 mm. So this is the patch dimension. You can do manual calculation or use online calculators to find it. So let's get started. So I already designed once. Let's start from the scratch. That's it. So under this draw tab, I'll click on this rectangle and draw a rectangle. Then click on this rectangle, create rectangle, and here I can access the value. Usually I'll be keeping the dimensions as variable so that I can change them when and where needed. Let's keep in axis is L. Let L be 19 mm. Along Y, W to be 23 mm. Press Ctrl D for a zoom out. Now again we have to center it. So this position I'll be changing it. For X it will be L by 2, minus L by 2. Along Y it should be minus W by 2. So I position my rectangle in the center. This is going to be my patch. Now let's create the substrate. The substrate dimensions actually depend on the scan requirement, but since here it is a single patch, so I am giving any arbitrary value. Let's say 50 mm along both the axes. And the Z size, it should be the size of the substrate. Actually, there are standard sizes of substrate that are available, so you can check on it. Similarly, I'll be positioning in the center, so in the X position it would be minus D by 2, and for Y position minus D by 2. Z should be at 0. So I got my substrate in the center. See. Now let's create the ground. Actually, it depends on how you model. As you start modeling, you will be able to find so many techniques. So here what I will do is I'll select the face, this bottom face. I'll click edit, surface, and create object from face. So I'll get a sheet at the bottom. I'll assign all the materials at the end. Now let's design the feed line. Again, I'll click on the rectangle. I'll just draw an arbitrary rectangle because I'll be modeling the values inside these properties. Along X, it will be the feed line length. So I'll put FL. Let it be 14 mm. And along Y, it would be the feed width. This will be FW. And it should be 2.3 or something like that. Again, for the line impedance, you can use online calculators for 50 ohm line. Now let's position the rectangle. Along X, it should be starting at edge of the patch, that is L by 2. And along Y, it should be minus feed width by 2. So now you can see the feed line has been positioned properly. Now I'm going to cut at this edge of the patch to make the proper inside feed. So again I'll create rectangle. I'll just create an arbitrary rectangle. Again I'll be modeling the values inside these properties. Along x, this will be the depth of the cut. So let us name it IL. Inset length will be 5.4, and y will be the width of this cut. That will be IG. Value will be 2 mm. Okay. So now I have positioned it towards the patch. So again I'll position it properly as needed. Along x, it should be starting at L by 2, and y, it should be starting from the edge of the feed width. So it should be FW by 2. Let's see. But I need to take it towards the patch. So I'll make the x size as minus IL. So it will go in the opposite direction. So the same thing I need to have a copy in the other side. So what will I do is I'll select this rectangle. I'll choose this mirror duplicate. I'll click at the origin and just drag my mouse towards negative y, so that the rectangle is duplicated in the minus y axis. So I have two rectangles which needs to be etched out of the patch. So now what I'll do is, first of all, I'll unite this patch and this feed length. I'll click these two, and just a second, I'll select these two and I'll click on this unite button. Now I need to etch out these two small rectangles for the inside feed. So similarly, I'll select this rectangle, and I'll also select the two rectangles which I desire to subtract. After selection, I'll click on this subtract button, and I'll click the blank part as the rectangle and the portions that I want to cut out in the tool part, and I'll click OK. So you can see my inside feeding is almost done. So now I'll be assigning the materials. Let's select the object here. I'll select this box. This is my substrate. I'll click on the material, edit, and type Rogers. Okay. So it's been assigned with the proper material. Now this box one, this is my ground. So I need to make it a PEC. So I'll right click on my mouse and assign boundaries and perfect electric. Okay. Similarly, I want my patch to be copper or PEC. So I'll follow the same steps. I'll assign boundary and select perfect electric. Press OK. So you can see my sheets. This both are assigned as perfect electric. Now let's just assign some color so that it looks good on the eyes. And my substrate. So we are almost done with the designing. Now I need to apply the feed. So what will I do is I'll click on the rectangle. I'll change this to YZ because I need to go downwards. Create this rectangle, and the Y size should be my feed width, and Z should be minus 0.76. That's the substrate thickness. The feed should run from the feed line to the ground, and the position along X has to be L by 2 plus my feed length FL. Now let's assign the required excitation into this rectangle. Let's also position it along the y-axis. Although it is positioned at the desired position, I'll keep it with the variables. It's done. So in order to assign, I'll click on this rectangle and right click on my mouse and assign excitation. Ports, lump ports, 50 ohm. I'll define the line of integration running from the bottom to the top. That's done. And do not renormalize. The design part is over now. I'll create the surrounding medium, create open region. The operating frequency will be 5 GHz. The boundary will be radiation, and click OK. Now at the solution setup, let the frequency will be 5 GHz. Maximum number of passes, just increase it in case it takes more number of passes. Click OK. Now define the sweep. Because my patch is designed for 5 GHz, I'll put it from 4.9 to 5.2. Let's minimize it. Click OK. So I'm done with this designing, and let's simulate it. Let's save the file first. Let's save it here. Patch. Now let's analyze it. So I've already designed the same model. It's already simulated. I'll not wait for the simulation again. The same design, the patch antenna with inside feeding, the ground plane. There is a reason why I'm giving it a sheet instead of 3D for the patch and the ground. The simulation time is reduced. So let's see the gain. I'm getting 8 dB gain, and the return loss, it is within, it's resonating at 5 GHz and has a bandwidth of 60 MHz. So you can improve this by fine-tuning the inset, this cut length and this gap, the feed line length. So you can optimize, and you can use the Smith chart tool to analyze where your curve is going. So now I'm going to design the same model in CST. So we'll click on this new template, and then we'll have an interface like this. Here I'm going to click on microwaves and RF. And then antennas. Next. Planar. Next. I'm going to use frequency domain that's recommended for resonant antennas, because patch being a resonant antenna. Units can be kept as it is. And min frequency, max frequency, this we can modify on the later stage also. So we'll keep these things as it is. Finish. Now we're going to click on modeling. Here we'll select this block and press escape. So I can dial in my values or variables in this dialog box. So my X, so now I'm going to create the patch. I'll name it as patch. Along X, I'm going to have my length, so minus L by 2 to L by 2. Along Y will be my width of the patch, it is minus W by 2 to W by 2. And because I'm going to create a sheet, so there won't be any height along side axis. The material would be PEC. Press OK. Put the values of L and width. So this is my patch. You can turn off this working plane. Now we're going to create the substrate. So the dimension is minus D by 2 to D by 2. Same for Y. Along Z, I have to go minus 0.76 mm downwards, because that's the thickness of my substrate. Yes, we're done. D is 50. So just click on done and OK. You can press the space bar to zoom out. Similarly, I'll have to create a ground plane here. So I'll click F and select this side of the substrate and click on this icon, shape from peaked face. So it's asking for the material. Since it's a ground plane, so it has to be PEC. Press OK. So the ground plane is done. Now I'm going to model the feed line. I can press on this block, press escape. Along X minimum, the starting point will be the edge of the patch. It is L by 2. It will go to feed length. So now for Y, it has to be minus FW by 2 to FW by 2. That's the width of the feed line. And since again it is a sheet, so it won't have any dimension in Z axis. And the material will be PEC. Press OK. The feed length is to be 14 and the width has to be 2.2. I'm keeping all the dimensions same as that in HFSS. So the patch and the feed line is done. Now we have to cut out some portion from the patch. So we'll again click on this block, press escape, and then along X, that is my size of the cut, length of the cut. It will be starting from L by 2, it's the edge of the patch, and it will go inside the patch. It has to be L by 2 and minus IL. Along Y, starting will be FW by 2. It will go till IG. Press OK. For IG is to be 2. Let's see whether it's properly made or not. Yeah, it's fine. So now we'll need to etch out a similar portion from the other side as well, other side of the feed line. So we'll click on this solid or this sheet and then transform. Click on transform and press on mirror. We like to mirror this and a copy, because if we do not select this copy, it will just transform this shape. It won't create any mirror. Now when I'm checking this box, it will have one copy of the mirror, and I would like to mirror along minus y axis. So I'll press -1. Let's preview it first. Yeah, it's correctly done. Now we'll press OK. So now I would like to add the patch and the feed line. So in case of CST, we have to select one material, one of the component, then come in this boolean and press add, and then select the sheet that I want to add. Select it and press enter. So now it is 1. Similarly, I would like to cut out these two portions. So I'm already selected the patch. Now I'll again go to boolean and press on subtract, and then select both of this material, both of this component actually, and press enter. So you can see that cutting has been done properly. Now let's assign the excitation. So we have to create a rectangle over here. Again, we click on this block, press escape. Along X, the position will be L by 2 plus FL, both for X min and X max, because it will be a sheet running from top to bottom, that is along that axis, and I don't want any thickness along X axis. And Y, feed width by 2, width by 2. For Z axis, the minimum will be minus 0.76. Let's keep it vacuum. That's okay. Again, press none. So, oops, it's been a slight error. Let's check it. Let's check it. Double click on it. So the position, it is along Y, along X, it is FL by 2 plus feed length. Oh, sorry, it should be L by 2. It is right, yes. Now I need to assign the excitation. For providing the excitation, we need to go to simulation, press on discrete port, and select the two edges of the rectangle. Let's look at this and hit the OK button. So we are done with the designing. Now we'll set the frequency 4.9 to 5.2. Press OK. unlike HFSS, we need to define here what are the fields that we want to check. So for that, I'll hit on the field monitor, and here we will get all the available uh, components that we want to see, either electric field or surface current. So I just want to check the far field. I'll click on this far field and set this frequency to 5 GHz and apply OK. That's it. Now I'm going to simulate this. To simulate, I'll click on Setup Solver and click on the Start button. Okay. So a design has already modeled, same design. I've already simulated this. We'll just go and check the results. This is the S parameter, the S11 return loss. Let's check in dB. So it's resonating at the 5 GHz only, but the matching is not as proper as we saw in HFSS. We can also see that in the Smith chart, it is shifted away from the matching point. So it needs fine tuning again. The purpose of this video is just to show you how to model, not to get the exact results. We'll come up with such video in near future. Just check the far field now. So as you can see, it is same as we achieved in HFSS. It's around 8 dB, or it's better even, 8.6 dB. So I'm ending the video over here. Hope you liked it. You can also recommend any other tutorial that you might want to watch. Thank you everyone.